Today we're going to do section 2.2D, which is rate of change in a linear relationship. You should be able to write rules for patterns. You should be able to understand how a relationship grows based on the rate of change. And we should be able to create tables, graphs, equations, geometric models, and identify the rate of change and initial value from those. All right, so right here we're looking at this graph. It shows the distance a cat is from its bowl of milk over time. The distance is on the y-axis, the time is on the x-axis. So let's use process of elimination and see which one of these is a good match. So A says the cat was 12 feet away from the milk and he ran toward it, reaching it after 4 seconds. Well, this is where the cat is. The cat starts at 0, so A is not legitimate. B says the cat was 4 feet away from the milk and ran toward it, reaching it after 12 seconds. Well, again, the cat is at 0. If it was 4 feet, it would start up here. So B, not an option. The cat ran away from the milk at a rate of 3 feet per second. Well, that could be it because we have the cat starting at the milk and running away. Now we have to check our rate. Remember, our rate is y divided by x. So 12 divided by 4, the rate is 3 feet per second. So your answer here is C. All right. Let's write everything you can say about the cat and the distance he is from the milk during his time. So the cat is actually starting at the bowl of milk. So the cat starts at the bowl of milk. And we said he's running away from the milk at a rate of 3 feet per second. You can say he's running at a constant rate. Those are the things that I have for that. So let's make a table now. So remember, the left is your x, so that's time, and the time is measured in seconds. And then this is the distance in feet. Here's your x, here's your y, okay? So at 0, he's on top of the bowl, so he's not away from the bowl at all. After 1 second, if our rate is 3, here's our unit rate right here. He's 3 feet away from the bowl. After 2 seconds, he's 3 more feet away from the bowl. After 3 seconds, 3 more in addition to that, so he's 9. And then 4, he's 12 feet away from the bowl. And look at how this matches up here. Okay? So is this proportional? That's 4. Is it proportional? Well, yes, because it goes through the origin. It starts at the origin. We said our unit rate here was y over x, or 3 feet per second. So the unit rate is 3 feet per second. We are already ahead of the game here. Let's move on to number 6. Okay, so what this wants us to do is a graph for the ones that we didn't use, the scenarios about the cat that we didn't use. So let's start with A. So make sure you label your first one, story A, so that we know what we're talking about. Story A says the cat was 12 feet away from the milk and ran toward it, reaching it after 4 seconds. So If we take that 12 and divide by 4, we're running toward it, so it has to be -4. So your rate is -3 feet per second. And you'll see that on the graph in just a second. So we're starting at 12. It's 12 feet away. Okay. So there's not a whole lot of room here, so let's just make a little mini table. And this is time, and this is feet. So we're starting at 12 and 0. So after 1, if you subtract 3, it's going to be at 9. After 2 seconds, it's going to be at 6, 3 seconds, 3, 4 seconds, 0. So after 1 second, it's at 9, 6, or 2 seconds, it's at 6, 3 seconds, it's at 3, and 4, it reaches the milk. So the x-axis is the milk. So you can see that when you have a negative rate of change, your graph is going to be downward sloping like a ski slope. Story B is another one we didn't use. The cat was 4 feet away from the milk and ran towards it after reaching it after 12 seconds. So we're going to start at the 4. So we're going to take 12. We're actually going to take 4 and divide it by 12. Sorry. So the rate is -1/3 feet per second. Remember, it's your y over your x, and your feet is the y, and the x is the y. So, we can make a little table here, or I'll show you just how to do it on the graph. So we're starting at 4, right? And it's probably going to be easier to do it by the graph. So this is rise, this is run. So after 1 second, so let's follow this first. This is our road map, okay? So we're going to go down 1 because that's -1 and over 3. And then keep going like that. Down 1 over 3. Down 1 over 3. Down 1 over 3. Okay? So it's hard to tell exactly where it is after 1 second, but we know that after 3 seconds, the cat is 3 feet away. And after 6 seconds, the cat is 2 feet away. And after 9 seconds, the cat is 1 feet away. And look, if the milk is the x-axis, after 12 seconds, it's got the milk. Okay, so you see, story D, make sure you label, the cat ran away from the milk at a rate of 4 feet per second. So the rate of change is 4 feet per second. And we're starting at 0, 0. So here it's easy to make the table again. So you have time over distance or feet. So 0, 0. After 1 second, there's your unit rate. The cat is 4 feet away. 2, cat is 8. 3, 12. 4, it's 16. That's going pretty fast. Story E is interesting. Let's take a look at story E. We never really got to this. Make sure again that you're labeling those graphs. The cat was 12 feet away from the milk and ran away from it at a rate of 4 feet per second. So the rate of change is right there, 4 feet per second. So here it's 12 feet away, so it's going to go up 4 over 1. So you're just going to have a little sliver there. That cat is running away. So at 1 second, the cat will be up here, 16 feet away. Very interesting. Okay, let's look at number 7 now. A baby was 9 feet from the edge of the porch. He crawled toward the edge for 6 seconds, then his mom picked him up just before he reached the edge. Circle the graph that matches this story. Well, let's use elimination. It was 9 feet away, so anything going through 0, that means that it was at the edge, so it can't be this one, right? So this one says it's 2 feet away, can't be that one, so it has to be either one of these two. So it says that he crawled towards the edge for 6 seconds. So here the time is 6, and then he stopped. So if we use this one, that poor thing would have gotten to the edge of the porch. But here, mom stopped him just a few feet before the edge. So that is the correct choice there. All right. Number 7. Let's go to number 8. The graph and the table below describe a runner's distance from the finish line in the last seconds of his race. Which equation tells the same story as the table and the graph? Use the ordered pairs given in the table to test your chosen equation and explain. All right, so we know there's a starting point of 42, and we can take our rate, 42, and divide by 6, or negative 6. So we get negative 7. It's downward facing, so he's getting closer to that finish line. So we know anything other, we're doing this format. Okay, and this is the rate, the M is the rate, the B is the initial value. So let's look at A. A can't be at A because the line would be going that way because of the positive 7. It can't be B because we know that our rate's not negative 6, and that's saying our rate's negative 6. So if you flip this around, there's our rate, and look, there's our starting point. So it's C. So the rate is negative 7, and the initial value, or the y-intercept, is 42. All right, create a table for this. So we have time and distance. So we start right here, 0, 5. Let's, oops, the 5 goes here, sorry. Let's find our rate. So I'm going to take 3 after 3 minutes or seconds, it really doesn't say. I'm at 23. We know that the rate of change is 6. So 1, and if you add 6 to that, you're at 11. 2, if you add 6 to that, you're at 17. So let's write a story for this. Let's say the dog starts at 5 feet away from the bone, and runs away at 6 feet per second.